Okay, good morning. Today we are going to be doing a lab about gravity. Yesterday in class we looked at the page that talks about observations, where we looked at 3 pictures of gravity and talked about scientific statements and scientific observations. Today we're going to flip to the next 4 pages of our science notebook. Now you're not going to go ahead and do that right now. You're going to go ahead and do that when we're all done, so I just need you listening right now. What you'll see, it says Gravity Lab. And then we have our phenomena question. Our phenomena question today is, why does our weight change on different celestial bodies? Then we have materials here, and it says scale, me, yardstick, and calculator. Now, if we were actually in class together, we would be doing this project together, and I'll explain as we go through how we would have done this together. I put the materials here in case you decide you really like this lab and you want to go ahead and do this lab with your family. So that's why I put all the materials. Now, the 2 things we're going to do today, we're going to figure out how much a person weighs on different planets, and we're going to measure out if they jump so far on Earth, how far would they be able to jump on other planets. So, the first thing we're going to do is we're going to have my trusty assistant. She's right here to help us. Meet Barbie. Okay? Barbie is our person that we are going to test. So, what I want to talk about, the first thing is mass versus weight. Now, mass is everything that makes up you. Your mass doesn't change, okay? If Barbie's on Earth, her mass is the same. If we take Barbie and we put her on the moon, her mass will stay the same. Her weight is going to change. And we're going to talk about that. So, I have my scale, and on my scale, I'm going to put Barbie. So, I'm weighing Barbie, and she weighs, we're going to pretend, 100 pounds. If she were a regular person, Barbie would weigh, we'll say, 100 pounds. So on my chart, where it says here weight on Earth, on all of these, I'm going to put 100 pounds. And I put that over here, weight on Earth, 100 pounds, 100 pounds. Now we're only going to do 2 together right now. You'll do the rest of these after class. Now, we're going to use a calculator today for this project. Whoops. So, turning my calculator on, and I want to figure out if Barbie weighs 100 pounds on Earth, how much does she weigh on the moon? So I'm going to take 100, which is the pounds, and I'm going to multiply it by this number right here. Multiply by 0.166. Okay? Because that's the gravitational pull on the moon. So I put 100 times 0.166. And I hit enter. How much does Barbie weigh on the moon?
16.6 pounds.
She weighs 16.6 pounds.
So on every one, Moon, Mercury, Venus, and the others, are we doing 100 times whatever
Yes.
it is, or are we?
Yes. We're pretending we're using Barbie, a 100-pound Barbie here, and we're going to see if she were 100 pounds on Earth, how much she would weigh on all the rest of these celestial bodies. So we're going to do the first 2 together, and I've already taken the picture of the chart that I completed in first block, and I've already put it into our Google Classroom. But I want you to be watching this to see what we're going to do. So now I'm going to take the next one, Mercury, and again I'm going to do 100 times, and this time the gravitational pull is 0.38. 0.38. If I figure it out, how much does Barbie weigh on Mercury? Bailey?
30 pounds.
38. She weighs 38 pounds on Mercury. Now, I'm going to do one more. Now, it's not written up here, but I'm going to take a really big one. I'm going to go for Jupiter. Okay? I'm going to go for Jupiter here. What am I going to multiply for Jupiter? Can you see it? Good. So I'm going to take 100 and I'm going to multiply it by 2.38. And my answer, how much is Barbie now going to weigh on Jupiter?
238.
She's going to weigh 238 pounds. Right? Has her mass changed? Has anything about Barbie herself changed?
No.
No. Only thing that has changed is her weight. What is the one thing that's changing in my multiplication problems?
The gravity.
The gravity, the gravitational pull, right? So what do we notice?
The numbers keep getting higher, farther away.
Okay, well, the moon is actually Mercury is closer, right? Let's think about the size of these planets. Look at the size. Looking at Jupiter, what's the biggest planet in our solar system?
Jupiter.
Jupiter, right? So if I were to look on my paper and I were to take off the sun, which number has the highest gravitational pull? Which has the biggest number in gravity? Jupiter, right? And we said Jupiter's the biggest planet. What is the biggest celestial body in our solar system?
The sun.
The sun, right? Look what we have to measure. It's the bottom one. Look what we have to multiply by on the sun.
0.
Not 0. It's the bottom one.
Oh. 28.
Yeah, we have to multiply it by 28. Not by any decimal. There's no 0 point or 2 point or anything. We're multiplying it by 28. So if I were to do that one right now, if I were to take 100 times 28, on the sun, Barbie would weigh 2,800 pounds.
Damn, she fat.
Okay, but here's the problem.
She hasn't changed her thing, her body.
You're right. It starts with an M. Do you remember what that word is?
Mass.
Her mass hasn't changed. What changed? Her
weight.
Her weight. Right? Her mass hasn't changed. Nothing about Barbie has changed. She still looks like this. Her weight changed because of gravity. You're right. Now let's see what gravity does if we were to be able to jump. Okay? So I have my yardstick. Thank you. I have my yardstick. Barbie's going to jump. Ready? Here she goes. Woo! Oh, that was one try. She got a 30. Okay, let's try again. Ready, Barbie? Woo! Up, 30. So Barbie is only able to jump 30 inches on Earth. Now, if we were doing this in the actual classroom and you guys were here, we would have taken yardsticks and lined them up, and you guys would have each jumped to see how far you can do just a standing jump. If you notice, Barbie didn't take a running jump. She was standing in one spot and she jumped. Okay? Barbie was pretty amazing, making it 30 inches on that standing jump all by herself, especially in heels. Anyway, the second chart you guys have says jump length on Earth, and I put 30 inches already. So all the way down we're going to type in 30 inches. I did make one mistake. It should say calculated length, not calculated weight, because it's the length. How far would she be able to jump on these other planets or celestial bodies? So we take the first one, and if you read the first one, it says 30 divided by 0.166. So I'm going to do that in my calculator. 30 divided by 0.166. And our answer is what?
180.
180.7. So I'm going to round it up, and I'm going to put 181 inches. Okay? Now if I do the next one, again, same thing, 30 divided by, this time 0.38 for Mercury. What's my number now?
78.
78.9. So what would I round that to?
1,000,000.
78.9, I would round it up to 79 inches.
I knew it.
Okay? So what's now happening with Barbie's jumps because of the gravity? She went from 30 inches to 181.
She can jump higher because there's no gravity.
She can jump farther, right? Because is there no gravity?
There's no atmosphere.
Well, there's no atmosphere, but is there no gravity?
There's gravity. There's
There's-
less than what's here.
It's less, you're right, with less
Yeah,
gravity.
there's
So what do you think would happen on the bigger planets or on the bigger celestial bodies?
You won't jump as far.
You don't think she'll jump as far? Should we try it?
Well, if she weighs more, you'd think she just wouldn't go that far.
Well, you're right, because she's going to weigh more, right? And with that heavier gravity, that gravitational pull, we're saying now that she's not going to be able to jump. So now, I'm going to try it again. I'm going to do 30 inches. I'm going to try by Jupiter, divided by 2.38 equals. How far is she jumping now?
120.
12.6 inches.
12 points. Yeah. 12 points. 13.
So I could round that to 13. Yeah, I could say 13 inches. So we went from 181 inches, 79 inches, 13 inches. I'm looking at my chart right now as I'm filling it out. Huh. What connection, what correlation do you see between the gravitational pull and the length of the jumps? We saw 181 with 0.166 gravitational pull, 79 inches with 0.38 gravitational pull, and then on Jupiter, she's only able to jump 13 inches. What do you think that would tell me?
The bigger the planet, the shorter your jump.
The bigger the planet, the shorter your jump will be. Yeah. Or the bigger the what? Not planet, but,
Bigger the mass.
well, the bigger the, 2 words, celestial,
Celestial body.
yes, you can. Celestial body. The bigger the celestial body, the more, oh, I almost lost my word. The what?
Gravity.
The more gravity it has. The more gravity or gravitational pull it has, the more we weigh, and the smaller we can jump.
Shorter we jump.
Yeah, we jump shorter. Right?
Yeah.
Yeah. So think about that. It's not just one of those fun activities where you go, oh, you have the website you could go to where you put in your weight and you see all the weights on the different planets. There's a reason behind it. It's because the bigger the planet, the bigger the gravitational pull it has on you.
Say we were actually, like, to go to that planet, we would have to wear a spacesuit, so we would weigh even more. So would we jump less? Because we would weigh even more with the spacesuit on.
Yeah, that's a great statement. You're right. We would weigh more because, you know, Barbie's going like this in her heels and her little dress. But if she were to go to space, she'd weigh more because she'd have on her full suit. So yeah, you'd weigh more, and then of course that would then cause you to be able to jump shorter. Great perception. Excellent. Now, what I want you to do is, we're still going to continue talking. I'm just going to finish up the video for a second. So, what you're going to do is, in the phenomena question, why does our weight change on different celestial bodies? This picture is in Google Classroom. It has the first 2 done of the weight and the first 2 done of the length. You're going to fill those out. All down this column, you're going to put 100 pounds because that's how much we pretend Barbie weighed. You're going to do the calculations. You can use your calculator. You can use your phone. You can use your computer calculator, whatever is going to help you. Okay? You're also going to do the length. And we said Barbie can jump 30 inches on Earth. So you're going to figure out for all of these, how far is she jumping? If you don't want to go ahead and round up to the nearest whole number, it's okay if you write all the numbers down that you see. I'm fine with that. So you're going to do this. Then page 4, writing our question again, and I want you to answer. And there are 4 words that will really help you when you go to answer. Gravity, mass, put them here. Gravity, mass, size, and weight. Those 4 questions will be very helpful when you go to write your conclusion.
Can you repeat the phenomena question real quick?
The phenomena question, why does our weight change on different celestial bodies?